We're going to take a look at trinomial factoring, trinomial with a equals 1. From the vocabulary, you should know that trinomial means we're going to have a 3-term polynomial. 1 term, 2 term, 3 term. That's why it's trinomial factoring. A technique you did very recently, which was called difference of two squares, used a binomial. Here we had 2 terms. As soon as we knew that we had 2 terms, we checked out these 3 questions to get our factored form. So the difference between what we're going to do today and what we did before is the number of terms in the polynomial. And to do this factoring, I'm going to always have you think about this sentence. This sentence is the equivalent of that 3-question checklist with the binomial difference of 2 squares. I'm going to leave these blank because this is going to change for every problem. But in this case, I would say to get this, the key is for me to figure out what pair of numbers multiplies to equal 10 but adds to equal 7. So this piece is always going to be the constant term, and this piece is always going to be the middle coefficient. So this sentence is one that really needs to be emblazoned inside your memory, because as soon as I know what 2 numbers multiply to 10, my constant term, and add to 7, my middle coefficient, I'm going to have the answer to my factored form. So when I ask myself what pair of numbers multiplies to 10, I can start making a list. 1 times 10 multiplies to 10. 2 times 5 multiplies to 10. And you would think we don't have any other numbers that multiply to 10, but here's a little tricky thing to remember. -1 and -10 also multiply to +10, and -2 and -5 also multiply to +10. So this is the full list of factors of 10, or it's the list of all numbers that multiply to equal 10. So from this list, can I find a pair that adds up to equal +7? So what I might do in a case like this is literally just add them. 1 plus 10 is 11. 2 plus 5 is 7. Ding, 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 ding. But I'm going to keep on. -1 plus 10 is -11. -2 plus -5 is -7. So here's a list of all things that multiply to 10 and what they add up to. This was my winner right here. A +2 and a +5. So as soon as I knew my winners, I put them into this form. X plus +5, X plus +2. They're in a different order than what you see here, but that's not a big deal. And I know that this is going to be a true correct answer because I'm always able to check myself in any factoring by distributing, in this case double distribution. And look what happens when I do this. When I do my double distribution, I end up back where I started, which means this was the factored form, the correct answer. Here's my next trinomial, and if I want to factor this, I have to ask myself, what pair of numbers multiply to equal 24 and then add to equal 14? Well, that means I need a list of all numbers I know of that multiply to 24. And so over here is my list. 1 times 24, 2 times 12, 3 times 8, and I even remembered my negative numbers because they're going to come into play here when we get more complicated questions. So this is the comprehensive list of all the factors of 24. That means you have to remember your multiplication stuff. So go ahead and write a thank you letter to your 4th grade teacher. Now when you have all these pairs, one of those pairs has to add to equal your middle coefficient, which is 14. And this one happens to be the 1. 2 plus 12 is 14. 2 times 12 is 24. That means that's the golden pair, the 2 and the 12, So that's going to be the answer to my factoring. And ta-da, there it is. And of course, because these two satisfied that sentence, I got to write them in there. And it didn't matter that I put the 12 first and the 2 second. That's okay. In this next trinomial, here's the question that goes through my head. What pair of numbers multiply to -8 and add to +2? Well, this is the first time we've had a negative in one of these problems, so watch what that means to us. Numbers that multiply to -8, -1 and +8, but I could also do +1 and -8. So notice that now I'm using signs in front of these. I could have done that in those previous examples, but you might have thought it was senseless because we didn't have to worry about negatives too much. But both of these multiply to -8, and in fact so does -2 times 4 and +2 times -4. So here's a list of all the numbers that multiply to -8. One of those pairs hopefully adds up to +2, and in this case, the third one down the line is where it happens. -2 plus 4 equals +2. So this is my golden pair, and so that means I just take those and I use that in the factored form. A +4 and a -2, x plus 4, x minus 2, I have my factored form. If you want to check yourself, you just go ahead and you do this distribution and make sure that you end up back there. So I've taken the time to do that check. I end up right back there. That means my factored form is good. I'm happy. I deserve another donut. Okay, on this very last question, I have a trinomial. So I'm going to go through this thinking. What pair of numbers multiply to 10 and add up to -11? Well, this one's also going to use negative numbers, but there's going to be a little bit of a surprise here. So I'm going to write out my list of all numbers that multiply to +10. This is pretty similar to one we did before. A +1 and a +10 multiply to +10. Same thing with 2 and 5. But here's where you might not think of including the negatives, but you have to. A -1 times a -10 gives me my +10. Same thing here. So forgetting the negatives is easy to do, but in this case it would get you, because we have to find the pair of these that adds to -11. And then if I would add these two, they would add to -11, making this my golden pair, and that's going to be my answer. X minus 10, x minus 1, there's the -10, there's the -1, and if I did the distribution, I would end up right back there, making me a happy guy. So on all these problems, you're going to need to have this question going through your head, which means you're going to need to make a list of the factors or the multiplying that goes to equal that constant term. That list has to include negative numbers as well as positive numbers. Once you find that list, you find out which two add up to that middle term, and you've got your golden pair. A quick word of disclaimer. We've ignored this, a equals 1, but this is a factoring technique that works when your leading coefficient is 1. Your leading coefficient isn't always going to be 1, in which case we'll have a different technique later.